if you are giving a velocity versus time graph to get displacement, it's just the area under the curve, right? So this is the area between the line and the x-axis. All right, so if you make that drawing between the line and the x-axis, if you get a square, oops, you like how I put that? The area of the square, not the triangle. Let's go. The area of the square equals base times height. And then what's going to happen is that means displacement is going to equal just velocity times time. Here we have the area of a triangle is 1/2 base times height. So the displacement is going to be 1/2 the velocity times the time. And then if you get this trapezoid, there's two ways to do it. You can add them separate. So the area of the rectangle plus the triangle equals base times height plus 1/2 base times height. So the displacement is equal to VT plus 1/2 VT. All right, so you would do your rectangle plus your triangle. So that's these two here. Okay, and then if you want to memorize the area of a trapezoid, you're more than welcome to. But for now, we'll go ahead and keep them separate because that's the preference of most people. Okay, so if I have a velocity versus time graph and I'm trying to figure out, am I moving right or am I moving left? Okay, to determine this, if we're moving right, the line of the graph is going to be above the x-axis. Okay, so that's your time axis. And this is the line is below the x-axis. And then for motion, we have three motions. We're either speeding up, slowing down, maintaining constant speed, or we are at rest. Okay, so these are the four options. If you are speeding up, then you are, and you have a velocity versus time graph, then you are moving away from the x-axis. If you're slowing down, you are moving toward the x-axis. If you're maintaining a non-zero speed, this is a horizontal line. This is going to be not on the x-axis. And then if you're not stopped or you're moving, you are on the x-axis. So this could be a horizontal line, it could be a point. So this is a line or a point. So sometimes we cross the time axis, then you're stopped for that moment. And then for acceleration, if I have a velocity versus time graph, it's positive if the slope is positive. So that looks like this. It's negative if the slope is negative. And it's 0 if it is horizontal line. Okay, and then to calculate this, acceleration is just delta V over T for all of these. Okay, so that would apply for all three. All right, so if we want to apply